In this lesson, we're going to be discussing how to evaluate limits, both analytically and graphically. So for example, if you're given this question, find the limit as x approaches to of x squared minus 4 over x minus 2. If you plug into this rational expression, we're going to get 2 squared minus 4 over 2 minus 2. 2 squared minus 4 is equals to 0 and 2 minus 2 is equals to 0. And so this is indeterminate. Now let's pick a number that is close to these two. Let's say 1.99 and also pick 2.01. Now this 1.99 is close to these two from the left, right, while 2.01 is close to these two from the right. So let's evaluate this limit as x approaches to from the left and see what we are going to get. So limit as x approaches to from the left. Then let's plug in 1.99 into this expression. So we have 1.99 square minus 4 over 1.99 minus 2. Let's also find in the value when x approaches 2 from the right hand side. So this is 2 from the right hand side. Let's plug in 2.01 into this. We have 2.01 square minus 4, 2.01 minus 2. So let's put this in our calculator and know what the answer will be. 1.99 square minus 4 divided by 1.99 minus 2. So this gives us 3.99, and then this one 2.01 square then minus 4 divided by 2.01 minus 2. So this gives us 4.01. Now this can be rounded off to 4. Also this can be rounded off to 4. So since the left hand side limit and the right hand side limit are equal, then this limit exists. But the question is, how do we get 4 from this question analytically? How do we solve this to get the value of 4? So let's continue. So in the case where direct substitution can't work because we directly substitute 2 here and we get 0 over 0, we try other means. So let's try and factorize this numerator. If we factorize this numerator, we have limit as x approaches to then x plus 2, because this is difference of 2 squares, then x minus 2 over x minus 2. As you can see, this and this has cancelled. We will be left with limit as x approaches 2 of x plus 2. So let's plug in the value of x, which is 2 here. So 2 plus 2 is equals to 4. So as you can see, we have gotten 4, which we got earlier. Let's solve another example. So let's evaluate this limit as x approaches 3 of x squared plus 3x plus 5. Now in this case, we can directly substitute 3 here, and then if you do that, we're going to have 3 squared plus 3 times 3 plus 5. 3 squared is equals to 9 plus 3 times 3 is 9 plus 5. So 9 plus 9 is 18. 18 plus 5 is equals to 23. And so this is the answer to this question. So let's solve one more example, simpler one. If x evaluate this limit as x approaches 2, then we are given x minus 2 into x squared plus 3x minus 2 divided by x squared minus 4. So as you can see, if you plug into here, 2 minus 2 is going to be 0. Then 0 multiplied by all of this is 0. Then 2 squared minus 4 is equals to 0. So what are we going to do next? Let's try and factorize. Now we can factorize this term here, right? Because yeah, it's not factorizable, but we can factorize x squared minus 2. So we have limit as x approaches 2 of x minus 2, and this can be factorizable. Then we apply the formula for difference of 2 squares here. It's going to be x plus 2, x minus 2. Now this and this has cancelled. We'll be left with x squared plus 3x minus 2 over x plus 2. So let's plug in the value of x, which is 2, into this expression. Now 2 squared is equals to 4 plus 3 times 2 is 6 minus 2 over 2 plus 2 is equals to 4. Now 4 plus 6 is 10, 10 minus 2 is 8. So we have 8 over 4. Then 8 over 4 is equals to 2. And then this is the answer to this question. And let's go ahead and solve the tougher ones. Hope you're understanding it. Let's evaluate this limit. Limit as x approaches 7 of 1 over x minus 1 over 7 over x minus 7. If you look at this numerator, you see that it's a combination of rational fractions. So each time you have this kind of question, you multiply both the numerator and the denominator by the SM of the fractions. So SM of 7 and x is equals to 7x. So we write limit as x approaches 7, 1 over x minus 1 over 7. We multiply this by 7x over, then multiply by 7x. We have limit as x approaches 7. Let's find the numerator. 7x multiplied by 1 over x is going to give us 7. Then minus 7x times 1 over 7 is going to give us x. Then we have over. We're going to leave this denominator the way it is. We have 7x divided by x minus 7. Because the main aim is to cancel out this x minus 7 in order for us not to get 0 at the denominator. So this is going to be equals to, here we have 7 minus x, and here we have x minus 7. So how do we write this 7 minus x to get x minus 1? So we're going to write limit as x approaches 7. Then we're going to factor out negative 1 from this numerator. If you factor negative 1, you just reverse their signs. Here, negative x will become positive x. Positive 7 will become negative 7. Then we have over 7x multiplied by x minus 7. So as you can see, x minus 7 and x minus 7 has cancelled. Then we are left with minus 1 over 7x. Now if we plug in x equals to 7 into this, we're going to have minus 1 over 7 times 7 is equals to 49. And then minus 1 over 49 is the answer to this given question. Let's go ahead and solve another question. Limit as x approaches 4 and of root x minus 2 over x minus 4. Now, in the case whereby you have only a radical at the numerator, we are going to multiply both sides, both numerator and the denominator, by the conjugate of the numerator. Right here, conjugate of root x minus 2 is equals to root x plus 2. So we write limit as x approaches 4. Then we have root x minus 2 over x minus 4. Let's multiply both the numerator and the denominator by the conjugate, which is x plus 2, and then x plus 2. So we're going to find the numerator. We have limit as x approaches 4. Root x minus x is equals to x. Then root x times 2 is equals to 2 root x. Minus 2 times root x is equals to minus 2 root x. Minus 2 times plus 2 is equals to minus 4. Then over, we're not going to find the denominator. Let's just write it the way it is. We have root x plus 2. We have limit as x approaches 4. We have x, then plus root x minus root x we cancel. We left with minus 4 at the numerator over x minus 4 multiplied by root x plus 2. This and this will cancel. We'll be left with only 1 over root x plus 2. So let's plug in the value of x, which is 4. So we have 1 over root 4 plus 2. This is 1 over root 4 is equals to 2. Then 2 plus 2 is equals to 4. We have 1 over 4 as the answer to this question. Let's find the limit as x approaches 4 of 1 over root x minus 1 over 2 over x minus 4. In the case whereby you have a rational fraction as the numerator and also a radical sign here, we're going to first of all multiply the numerator and the denominator by the LCM of this, which is 2 root x, and then after that we multiply again the numerator and the denominator by the conjugate of the numerator. So let's start with this one. We have limit as x approaches 4. We have 1 over root x, so this is minus 1 over 2. Then let's multiply this by the LCM, which is 2 root x, then over, let's not forget this, over x minus 4 multiplied by 2 root x. So 2 root x times 1 over root x. Okay, let me write this first. X approaches 4. Then 2 root x times 1 over root x is equals to 2. Then minus 2 root x times 1 over 2 is equals to root x. Then this will be over, let's not for the denominator, we have 2 root x into x minus 4. So then we have limit as x approaches 4. The next we're going to do is to multiply the numerator and the denominator by the conjugate of the numerator. So we have 2 minus root x over 2 root x multiplied by x minus 4. Then we have 2 plus root x over 2 plus root x. So we have limit as x approaches 4. 2 times 2 here is equals to 4. Then 2 times plus root x is equals to plus 2 root x. Then negative root x times 2 is equals to negative 2 root x. Then negative root x times positive root x is equals to minus x. Then this will be over, we're not going to find the denominator, so we have 2 plus root x multiplied by 2 root x multiplied by x minus 4. So we have limit as x approaches 4. Then we have this plus root x and minus root x will cancel. We'll be left with 4 minus x. Then this is over 2 plus root x multiplied by 2 root x multiplied by x minus 4. So we have limit as x approaches 4. So as you can see, we have 4 minus x here and we have x minus 4. So in order to cancel out these two terms, let's factor out negative 1 from the numerator. If we factor out negative 1, we're going to reverse their signs. Minus x becomes plus x, and then plus 4 becomes minus 4. Then this is over 2 plus root x multiplied by 2 root x multiplied by x minus 4. This and this will cancel. Then we'll be left with limit as x approaches 4 of minus 1 over 2 plus root x multiplied by 2 root x. So let's plug in the value of 4 into this whole expression. We're going to have minus 1 over 2 plus root 4, then multiply by 2 times root 4. So this is equals to minus 1 over 2 plus root 4 is equals to 2, then multiply by root 4 is equals to 2. 2 times 2 is equals to 4. So this is equals to minus 1 over 2 plus 2 is 4. 4 times 4 is 16. So this is the answer to this question. Let's evaluate the limit as x approaches 2 of this absolute value function s minus 2 over s minus 2. That's the absolute value of x minus 2 over s minus 2. And if we plug into here, we have 2 minus 2 over 2 minus 2. So 2 minus 2 is 0, then over 2 minus 2 here is also 0. So this is indeterminate. How do we solve this question now? Well, we are going to find the left-hand limit of this question. So as x approaches negative, 2 from the negative side. So let's plug in 1.99 into this expression. So I have 1.99 minus 2 over 1.99 minus 2. So you have absolute value of 1.99 minus 2 divided by 1.99 minus 2. So this is equals to negative 1. Let's evaluate it again from the right hand side. So we have 2.01 minus 2 in absolute value sign over 2.01 minus 2. Let's know the answer we are going to have. So we have 2.01 minus 2 divided by 2.01. So this is equals to 1. So as you can see, the left hand limit and the right hand limit are not the same. So the limit to this one does not exist. So this limit as x tends to 2 of absolute value of x minus 2 over x minus 2, the limit does not exist. So let's discuss graphical method of solving limits. We have x here, and then negative x, we have positive y, and then negative y. Now, using graph to solve limits, we'll be considering the left-hand limit and the right-hand limit. So let's evaluate the limit as x approaches negative 2. So as x approaches negative 2, we're going to be considering this from the left-hand side and then from the right-hand side. So from the left-hand side, you follow this curve. So as it approaches these two, the answer here is positive 1. So from the left-hand side, you have that the limit is equals to 1, positive 1. Then from the right-hand side, you follow this curve. So the answer here is 2. Alright. So from the right-hand side, the limit is equals to positive 2. So as you can see, these two answers are not the same. Alright, so we say that the limit as x approaches 2 in itself does not exist. Let's find f of 2. Now, at any point on this graph, on this line, you pick a y value that corresponds to a point with closed dot or closed circle. So in this case, this value of y, which is 1, corresponds to this closed dot or circle. So f of 2 is equals to 1. Alright, so this is about when x approaches 2. So another question we're going to solve is when x approaches 1. Let's find the limit and know if the limit exists or it does not exist. So the limit as x approaches 1, we're going to be looking at it from the left hand side, also from the right hand side. So the limit as x approaches 1 in itself, whether it exists or not, and then also we're going to find the value of f of x at that 1. So here, the limit as x approaches 1 from the left hand side, so we're going to follow this curve from the left hand side. The answer is equals to 4. So this is equals to 4. Then the limit as x approaches 1 from the right hand side, we're going to follow this curve. Then this curve, this is equals to 2. Alright, we are picking the y values 2. So what is the limit as x approaches 1? Now because these two answers are not the same, then the limit as x approaches 1 does not exist. Now for f of 1, so we trace this point which is at 1, then pick the y value that corresponds to a closed dot. Right, in this case the answer is equals to 3. So f of 1 is equals to 3. And then this is it for this one. So finally, let's concentrate on this hole here. Sorry, this hole is meant to be on 3. So sorry for that. Let's consider that one. So evaluate limit as x approaches 3. So we're going to be looking at it from the left hand side. Again, we look at it from the right hand side, and then we'll find the limit as x approaches 3 on its own, know whether it exists, and then find f of 3. Now let me put this dot, let me put a dot here. Alright, so for the sake of the last one, so I want you to try this and know if you can get it. Just, it's very simple. So here we're going to limit when x approaches 3, we're going to follow this curve. So here is this dot here, and then the limit is equals to 1. Alright, positive 1. Then the limit as x approaches 3 from the right hand side, we follow this curve again. We say the limit here is also equals to 1. Then the limit as x approaches 3 on its own is equals to 1, because the left hand limit and the right hand limit are the same. So the limit at x approaches 3 is equals to 1. Now f of 3 at this point, or this line on 3, you choose the y value that corresponds to a point there. So this is the point, and then the y value there is equals to 2. So f of 3 is equals to 2. And then this is it for this video. Thank you for watching. Please feel free to subscribe to my YouTube channel, turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. Also, don't forget to like, comment, and share with your friends. See you in my next video.